Let's talk about carbon dioxide gas. Okay. Now, if you were to draw carbon dioxide, all right, once again at a molecular level, okay, example, carbon dioxide, CO2, all right, you would be able, I hope you can visualize this carbon dioxide. I'm not saying draw dot and cross. If I ask to draw a sample of carbon dioxide gas, all right, you need to be able to draw this. Okay, so that's number one. Now, number two, okay, and I think some students don't know this, right? You need to be able to label where your covalent bonds are and where your intermolecular forces of attraction are. Okay, now where is the covalent bond? Okay, some say between molecules, some say between the elements, between the carbon oxygen. So careful, huh? The covalent bond is here. Covalent bond. The covalent bond, if you don't recall, is the shared pair of electrons. All right, okay. So watch out for that. All right. On the other hand, your intermolecular, it's the one between molecules. These are your intermolecular. Okay. So watch out for that. Now, next question. Covalent bond. Okay. Let me know covalent bond. Is it strong or is it weak? Okay. I'm going to also try and make it a bit more interesting. Three properties. Remember, it got low melting point and boiling point. Number two, it is insoluble in water. Basically opposite then. Opposite of ionic. Does not conduct electricity. So my question here is this. The covalent bond, is it strong or weak? Covalent bonds are strong. Your intermolecular, hey friend, don't scare me. These are called intermolecular forces of attraction. Intermolecular forces of attraction. There is no such thing as intermolecular bond. Okay? Your intermolecular forces of attraction, weak. Once again, if you didn't catch it, I need you to understand this. Your intermolecular forces of attraction are weak. And your covalent bond is strong. Please make sure you understand this. Now, a lot of students will always forget. They will say, oh teacher, the melting boiling point low, ma. Therefore the covalent bond should be weak, which is super wrong. No, the covalent bond is the bond between the atoms. And when you melt and boil a substance, you don't break the covalent bonds. You overcome the weak intermolecular forces of attraction. So just watch out for that. Okay, so this is like the first misconception. I would say if you make this mistake, you probably didn't pass your exam. So just watch out for that. Okay, when do you break the covalent bond? I would say mostly never. Unless you talk about, say, maybe water, then you use electrolysis, you break down the covalent bond. Your water molecule become hydrogen and oxygen. But if not, when you are melting and boiling carbon dioxide gas, carbon dioxide liquid, carbon dioxide solid, or carbon dioxide, the covalent bond does not break. You overcome the intermolecular force of attraction. Okay, so just watch out for that. Okay, so I'm going to try now. Second one, okay? Same thing, if you're here in my weekly class, you should be able to answer this. And my next question here is this, okay? Let's use, say, let's do something reasonable. Oxygen versus ozone. We did ozone last week, right? Which has a higher boiling point, and why? So the answer is this: ozone. Okay, now you must understand this. This one, same thing. Some of your schools, you sat for your paper, it came out. All right, okay. Now, ozone has a higher boiling point. Why? Ozone has a larger molecular size. Hence, intermolecular forces of attraction are stronger. More heat energy needed to overcome. Now notice, I never ever say break because we don't break. Okay? Later on, I'll tell you when to use the word break. Careful, huh? Can? Any questions so far? Why would forces be stronger? Can. So maybe it took you a while to type that because let me try. So here. Now, I'm going to draw another oxygen molecule just above it, and I'm going to draw another ozone molecule just above it. Think about it in terms of surface area. All right, here you have intermolecular forces, and imagine they are spaced out equally. I have just more. All right, but in chemistry we don't say more, we say strong. You buy a pair of magnets from Popular. You either get a pair of stronger magnets or weaker magnets. Stronger magnets, the force of attraction is stronger. You don't say it's more. All right, okay. So, or you don't say there's more force of attraction. No. Here you have weaker intermolecular force of attraction. Here you have stronger intermolecular force of attraction. Okay. I hope that answers your question.